Today I'm going to show you about resistance. So I've got a power supply here and I've got two cables coming from the direct current, positive and negative. I have some crocodile clips which I'm going to pop on the end. And I have some steel wool. So you might have seen this bunched up quite a bit more than that on maybe a scouring pad or a sponge used for washing up at home. Now this is made of very, very thin pieces of steel or iron, okay? And what we're going to do is we're going to pass a current through this because we can use these pieces of metal as like a wire. So if I clip one end on here and the other one on here and turn on the power, you can see that nothing happens to begin with. Now if we turn up the voltage, you can see an interesting effect begin to occur. We get both light and heat as the iron reacts with oxygen. Now what's happening is, as the electrical current is passing through the iron, it is resisted by it. Okay, so this is a bit like the electrical equivalent of friction, and the more resistance there is, in the same way that the faster or the more force you push with, the more friction you get back, in the same way with this, as we increase the voltage on the current, then we're trying to push more electricity through the wire at once, and there is more resistance. And much like with friction, you can get a carpet burn, or you can heat up your hands by rubbing them together. Resistance generates heat. So the energy is being converted from electrical energy to heat energy. And in this case, when you take steel wool and you heat it up enough, it reacts with the air and reacts with the oxygen and forms iron oxide and generates that heat and light. So this is something we need to be aware of when we're making electrical circuits, and it's also something that we can use to our advantage. So you may have seen an object like this before. This is a fuse, and it has a wire running through the middle which burns out in the same way that we saw this happening. And that only happens when the current passing through becomes too great. So it's a useful safety feature, and when you often get them in plug sockets and that sort of thing. So if too much power is coming from your supply, then before you damage your equipment, the fuse will go instead, and then you just have to replace a little bit of your circuit instead of the whole thing. So we also have a bulb here, and that takes advantage of the same effect in that the wire in the middle gives off light because of the resistance, but it's not surrounded by oxygen, so it doesn't react with it and combust in the same fashion.